The Oracle Autonomous Database, the world's first self-driving database. So relax, everything's automated. Human error is eliminated. A revolutionary new technology called machine learning enables the database to protect and repair itself without ever having to stop. The database automatically responds to cyber attacks and prevents data theft. In a world striving to build self-driving cars, Oracle has built a self-driving database. Fully automated, ever vigilant. Your data is safe. In the Oracle Autonomous Database Cloud.
Ladies and gentlemen, please welcome Larry Ellison.
Hi, everybody. I'm sure you're curious, did I also do the drawings on that last ad? The fact is, no, that was a collaboration. But okay, today I'd like to talk about the second generation of our cloud, featuring Star Wars cyber defenses. To protect our Generation 2 cloud, we've had to re-architect it from the ground up and introduce Star Wars defenses, impenetrable barriers or force fields, and autonomous robots. The combination of those two things protect your data and protect our Generation 2 cloud. Okay, the current state of the art of cloud defenses, just not good enough, not even close. The smartest technology companies are routinely penetrated, and you can read about how vast quantities of their data is stolen. The most security-conscious government agencies are also vulnerable. If the smartest among us, the most security-conscious among us, have been attacked successfully, this is a big problem. The attacks are getting more frequent, the attackers are getting smarter, and our businesses, our data is more vulnerable. As a result of this, Oracle has gone through a period of fundamentally re-architecting our cloud. We built a Generation 2 cloud. And we built in, again, these Star Wars cyber defenses. Now, it's easy to say, very hard to do, to build a secure cloud. If it was easy to do, someone would have already done it. We've been working on it for a long time. As I said, it required a fundamental re-architecture of our cloud. And we did that. And as a result, we have these two key technologies that protect the cloud and protect your data. Impenetrable barriers block threats from getting into the cloud. And then autonomous robots find those threats and kill them. To re-architect the cloud, I'm not talking about a few software changes here and a few software changes there. I'm talking about a completely new hardware configuration for the cloud. It starts with the foundation of the hardware. We had to add a new network of dedicated independent computers to basically surround the perimeter of our cloud. These are computers you don't find in other clouds. A whole new network of dedicated computers to form this impenetrable barrier. And it not only protects the perimeter of our cloud, keeps threats from getting in, these barriers also surround each individual customer zone in our cloud. So threats cannot spread from one customer area to another. So one customer, a malicious customer, can't move laterally in our cloud and see the data and get at the data of other customers. That required a completely new hardware configuration as well as new software. Then we used the latest technology, the latest AI machine learning technology, to build autonomous robots to go out and search and destroy threats that are inside of our cloud. Now, we talked about for a long time we have an autonomous database. And the autonomous database is autonomous because it has a bunch of robots doing things. It has robots that automatically tune the database. It has robots that automatically back up the database, that recover the database when the database goes down. Shouldn't ever go down, but if it recovers it if it does. Now we've added lots more robots to protect every aspect of the cloud. And it has to be robots. In the old days, and the way most people operate today, is if a vulnerability is found in your database, if vulnerability is found in your applications, in your systems, human beings then decide, how do I schedule a downtime window? I need to take that system down and then patch it. And by the way, I've got to find all the related systems. If it's a Strut system, I've got to find all the Strut systems and patch all the Apache Strut systems. I've got to locate them all. See which ones I can take down now, which ones I can take down later, schedule patching, do all of that. In other words, it's a bunch of people trying to defend your data against a robot or botnet attack. It's their robots versus your people. Who do you think's faster? Who do you think's going to win? It's got to be a case where this is completely automated, it's autonomous. A database threat is discovered automatically. No human beings are involved. The patch is immediately applied while the database is running. No downtime window has to be found. You can patch the system while it still runs. This is essential for protecting our data and protecting our cloud. Here's the problem. The Generation 1 cloud has these very simple, great price performance Intel commodity computers. They're great machines. We use them too. 2-socket machines. And you can have multiple customers in the same machine. No problem. Well, maybe a problem. But that's not the biggest problem. If you look at the AWS cloud, in that machine could be one customer, could be multiple customers, but in that machine is the AWS cloud control code sharing the computer with customer code. That means you better trust your customers. You better trust all your customers. If you're going to let your customers inject code or use the computer that you use to control the cloud, if you're going to let customers share that computer, the computer you use to control your cloud, and those customers are smart, they can look at your cloud control code. They can change your cloud control code. They can move from one computer to the other. They can look at other customers' data. They can schedule the other customer's data is exfiltrated out of the cloud someplace else. And they can make sure that you get the bill twice. You pay for the exfil, and your data is lost. If you have a single shared computer running your cloud and running your customer code, one customer can see the other customer's data, Amazon can see your data, and the customers can change the Amazon code and hack the system and take control of the code and steal data. It's a big problem. It's a fundamental problem with the architecture of the cloud. What we have done on the right with our Gen 2 cloud is we have customer computers that the customers can use. We call them bare metal computers, by the way, and I'll show you a little more detailed picture. But you could have one customer in the bare metal computer. You could even have multiple customers in the bare metal computer. Some customers will choose to have that computer all to themselves. Some customers will say, well, I don't really care. I'm very cost sensitive. I'm happy to share the computer with other customers. It depends. But we will never put our cloud control code in the same computer that has customer code. That creates an incredible vulnerability to our cloud control system. So we've added a completely separate network of dedicated cloud control computers that not only protect the perimeter of the cloud, protect threats from coming from the outside and getting into the cloud, but we also form a perimeter around each individual customer zone. So customers can't get out of their zone and into your zone. And they can't hack our cloud control computer because there's no way to access it. There's no access to our cloud control computer. They can't look at the memory. They can't add code. They can't do anything to it. It's an isolated network they can't get at. We can't look at your data, which is nice. But the most important thing, they can't look at our control code. They can't change our control code. Okay. So this impenetrable barrier created by the cloud control computers not only surrounds the perimeter, but just as importantly, surrounds and isolates every individual customer zone. Threats can't enter and threats can't spread. It's a big deal. All right, I'd like to clean up some naming. I'll use 3 different names, and they sound synonymous, but they're subtly different. I'll talk about our Generation 2 cloud. By the way, this is a picture of what we call Oracle Cloud Infrastructure. OCI is our 2nd generation cloud infrastructure. Look at the top line, and the box in the upper left-hand corner says bare metal. That's a bare metal server. This is a server that users can rent that has none of our code on it. And the users can have that all to themselves. So no other user can, if that's what you want, you can have a series of these bare metal servers, only your code on it, only your customer, no other customer's code, and certainly none of our code. So you don't have to trust us. No offense, we don't trust you. Well, we trust you, but we don't trust all of you. If you know what I mean. I say we've got a bare metal server, and we also have VMs. We have Exadata in our cloud infrastructure. So if you're running our database, you can run it on a shared Exadata, as you'll see, and I'm going to announce in a few minutes. You can also run it on dedicated Exadata infrastructure. You're the only one using that Exadata machine. You can isolate yourself there. So you can isolate yourself on bare metal computers. Customers can have their own computers, their own Exadata machines, and their entire perimeter sealed off by our cloud control computers. Other customers can't look at your data. We can't look at your data. Okay, this whole picture is the picture of our Oracle Cloud infrastructure, our Gen 2 infrastructure. What's not shown is the entire Gen 2 cloud, which includes our Fusions, things like our Fusion SaaS apps. They show another layer on top of that. So when I talk about the Gen 2 cloud, I'm going to also talk about Gen 2 infrastructure. Slightly different. The infrastructure doesn't include the analytics services, doesn't include the apps. A lot of people will talk about our bare metal cloud. Some people call the infrastructure our bare metal cloud. Actually, that's not quite accurate either. Bare metal is a key component of OCI, Gen 2 OCI, but it is not all of a Gen 2 OCI. We have bare metal compute servers with the classic 2-socket Intel machine. We have dedicated Exadata machines. We have a lot of stuff in our Gen 2 cloud, in our Gen 2 infrastructure. Bare metal is just a key and important piece. All right, so the primary reason we re-architected our cloud from the ground up was security. Security built in from the center to the outside, from the perimeter to the inside. Impenetrable barriers, autonomous robots. But there are other reasons we built Gen 2 of the cloud. As long as we're rebuilding our cloud, as long as we're re-architecting our cloud, there were other design goals. And another design goal is we want to make it very, very easy for you to move your existing data center, your existing workloads into the cloud. An SAP application running on an Oracle database, just lift it up intact with all of its customizations and everything, drop it down in our cloud. E-business suite, any bespoke, any custom application you have, especially an Oracle database-based application, lift it up, move it over, no fuss, no muss, press a button, very, very easy to do. That's not what most clouds do. That's not what they were designed to do 10 years ago. We want to make it very easy. Our goal has always been, as we move from one generation of computing to the next, as we move from mainframes to mini computers, to client-server PC networks, to internet architecture, to the cloud, every generation we want to protect your investment in data, in applications, in all that code, and make it easy for you to lift that stuff up, move to the next generation, and take full advantage of the next generation. We did that with the Gen 2 cloud. And the Gen 2 cloud add a lot of automation. So save labor costs, eliminate errors through automation. And the overall price performance should be much better, is much better than you get on-premise. Okay, other clouds have been around for a long time. They were not really designed for the enterprise. Security is not good at the current state of the art. And believe it or not, if you move an on-premise application into the cloud, it will cost you more, not less, to run, typically. Okay. All right. The Oracle Generation 2 Cloud, again, the design goal, one platform, one secure platform to run everything, all your applications. The Oracle Autonomous Database was built on top of the Gen 2 infrastructure. Our new SaaS, all the Fusion SaaS applications today are already running on, not every customer on SaaS, but we've already got the Fusion applications and the NetSuite applications running on the Gen 2 cloud infrastructure. It's designed to run all of your existing enterprise applications, lift them up, move them over. But also cloud-native applications, using the coolest new cloud technologies, Docker containers, Kubernetes, your favorite open source stack, bring it, we run it. It's probably there, you don't even have to bring it. We've got all that stuff waiting for you. So you can build cloud-native applications in the same environment, our Gen 2 infrastructure, that you run your enterprise applications. Gen 2 is available now in the public cloud and is available next year with Cloud@Customer. Customer. Oops, back it up one slide, I'm sorry. And if you got database Cloud@Customer, Customer, this is very important, I think. If you're currently bought database Cloud@Customer, Customer, come this next summer, you can press a button and we'll upgrade you, free upgrade, automatic upgrade from Gen 1 database Cloud@Customer Customer to Gen 2 autonomous database Cloud@Customer Customer. So with Gen 2, we can actually deliver our autonomous database to your premises in the form of database cloud at customer Gen 2. So we're very excited about that, and it's an easy upgrade for what's proving to be a very popular product, our database cloud at customer. All right, other design goals. Again, as you move to the cloud, we want to provide better functionality and better performance than you have on premises. All the latest tools, Exadata, Rack, DataGuard, everything. Give you a choice between bare metal compute and sharing compute with other customers via VMs. It's your choice. Much more automation. Upgrades are automated for you. Patches are automated for you. Press a button, migrate a workload. Very important, easy to build a big pipe between your data center and our cloud. And you'll see that we don't charge you a lot of money for moving data back and forth in and out of our cloud. And we guarantee performance. Because we don't oversubscribe our infrastructure, we can guarantee, we'll give you an SLA. We'll give you an SLA to guarantee your performance. Nobody else does that. All right. Two things are true about Gen 2 cloud infrastructure, our Gen 2 cloud infrastructure. It's faster than any other cloud. It should be. It's newer. It's brand new. And we priced it very aggressively. The combination of being much faster and being aggressively priced is good for you because we're just much cheaper than the competition. All right, we'll compare ourselves to Amazon. And here, just plain old raw compute. We're 50%, almost 50% faster in compute. 5 times faster in block storage. This is just performance, not cost. The next slide is cost. Cost is even better. So we're 50% faster in compute, 5 times faster in block storage, and twice as fast networking. But when you compare price, Amazon's basic compute is triple our basic compute. When you move to our cloud, you do save money. You move to their cloud, actually costs you more. Their block storage costs 30 times what our block storage costs, and their networking, again, you move data out of the Amazon cloud, bad idea, because it costs more to move your data out of the Amazon cloud than it costs you to move your data out of the Oracle cloud. We believe you should be able to move data back and forth. Amazon's pricing is very clear. Move data in, you're done. Block storage, 6 times faster, but 97% cheaper. So performance advantage significant, 6. Price advantage much more significant. Big data workloads, this is a TerraSort workload, by the way. It's a big data workload, we're 3x faster, but again, 80%, more than 80% cheaper. Huge, huge cost differences. The cost differences are much bigger than the performance differences. The cost savings is much more than the performance advantage. Because it's a combination, our cost savings is a combination of being faster and being priced more aggressively. We have this new RDMA network that's remote direct memory access. It's really the ability of computers that are networked together to move data from one computer directly into the other computer without taking an operating system hit, without an interrupt. It just goes direct from one spot to the other. It creates a very low latency network. You can move data very, very fast. By the way, it's how Exadata works. Exadata has an RDMA. The way the Exadata machines are connected, one of the reasons why Exadata is so fast is because it has an RDMA network. And now we've used the RDMA network in lots of areas of our cloud to cluster machines together. Gives you 1.5 microsecond latency, very low latency, and huge bandwidth, 100 gig bandwidth. And this is a computational fluid. It's a scientific workload, an engineering simulation. CFD, computational fluid dynamics, a bunch of partial differential equations. Doesn't really matter what it is. The fact is, we run this 4 times faster and much cheaper, much cheaper than Amazon. Same, more examples of CFDs, computational fluid dynamics, more simulations. We just run faster, big performance advantage, much bigger price advantage compared to Amazon. Okay, our Gen 2 cloud, security, security, security. Star Wars cyber defenses. So we've used a lot of the latest artificial intelligence and machine learning technologies to build these robots to protect the cloud infrastructure, to find threats and kill them, to search and destroy. Our robots versus their robots. You're not fighting with both your hands tied behind your back anymore. We protect against distributed denial of service attacks. We have web application firewall to look at messages coming into inspecting the messages coming into web applications. The autonomous database we've already talked about. Obviously, we manage all of our resources. We keep track of we keep track of users, and we keep track of what resources users are allowed to look at. The autonomous database automatically discovers threats, automatically repairs threats while running. Everything's encrypted, of course, at rest and in transit. We have a key management system where you can manage the keys to your own data. It's backed up, again, it's got a hardware security module that allows you to manage the entire life cycle of your encryption keys. This is, again, a very big deal. You don't have to trust us. After all, I just said earlier, we don't trust you, not all of you. So you don't need to trust us. That's very important. You want to manage your encryption keys? God bless you. You do it. We provide all the tools, to help you do it in an efficient and a secure way. The cloud controlled computers, the new architecture, these impenetrable barriers protecting the cloud perimeter and every user from every other user. Full physical isolation from other tenants is built in. That's why we re-architected our cloud. I mentioned the key management service. Lets you manage your own keys. Of course, we have a CASB, Cloud Access Security Broker. We're constantly looking around for threats. We started with the autonomous database, trying to identify threats. Now we're looking for threats throughout the cloud with all of the assets that we're managing. Search, autonomous robots, search and destroy threats. We check for configuration changes. Anomalous configuration changes. People going in, and that's what they do when people with threats. They start changing your configuration. They make all of these alterations. We look for those things, and if someone maliciously changes the configuration, we discover that, restore the configuration, kill the threat. Web application firewall protects your infrastructure-based applications, and our denial of service protections guarantee you bandwidth, even with a huge attack, designed to manage through the worst, layer 3 and layer 4 attacks, and still make sure your service is running. Okay, in 2019, this is what our footprint looks like globally with our Generation 2 cloud. But that's not every location we're supporting. In fact, we just added another location, I think, agreed to add something in UAE, I think yesterday or the day before. So we're continuously adding to this. But on top of that, we're willing to build additional locations for our Gen 2 cloud. We're willing to build our Gen 2 cloud on your data center floor, just for you. No caveats, identical to what we have in our public cloud. with the barrier, with the cloud control computers, all the autonomous robots, everything, we will put in your data center just for you, for our most security conscious customers, for our customers that want to have the broadest bandwidth between their data center and our cloud. We'll put the cloud, we'll co-locate them. We will co-locate them. Okay, when you come to Oracle and you buy infrastructure and database services, you get our Gen 2 cloud now. That's the only thing we are selling across the cloud. We are dedicated to this new secure cloud. It's the only thing we are selling. As I said, everything's going in that direction. All of our SaaS applications, all of our customers, we think this is what we should be doing. This is what you get. Our clouded customer, which is Gen 1, for a few more months, don't worry. We think that's a terrific product, and come summer, press a button, and you get all the autonomous services with it. We sell all the appropriate hardware. When we deliver the Gen 1 database clouded customer, we deliver the Exadatas, all the appropriate gear. So when we have the Gen 2 stuff ready, for clouded customer, you push a button, upgrade that software, you get it automatically. And I think that's, and that's been our database clouded customer has been one of our most popular products, and we make it easy for all of those customers to upgrade. And then, as I just mentioned, full OCI, everything, bare metal, you name it, everything. Load balancers, blah, blah, everything. Autonomous robot. You can get that also in 2019. Okay. That's our Gen 2 cloud. The most important component, perhaps, of the Gen 2 cloud is our autonomous database. And we've made a lot of progress over the last 12 months since we gathered here last year. But the autonomous database, we've announced last year, we announced for data warehousing, and then a few months ago we announced the autonomous database now also handles transaction processing. So it really handles all of your workloads. And when I mean autonomous, I mean autonomous. I read an article, by the way, Amazon did not write the article. Someone was writing the article saying, well, Oracle may have an autonomous database, but Amazon is developing these semi-autonomous databases. Semi-autonomous databases like a semi-self-driving car. You get in, you drive, and you die. I don't even know what it is. I mean, okay, whatever. This thing is fully automated, fully self-driving. It provisions itself. It gets servers. It gets I/O. It gets network capacity. If the load grows, it automatically scales itself. It automatically creates and drops indexes. All the security is automatic. If there's a threat that's discovered, the threat is killed automatically while the database is still running. If the server fails, database server fails, the database keeps running. If the database software fails, the database keeps running. It automatically backs up itself, it automatically recovers itself, etc. It's fully automated. It really is self-driving. No one's going to die. And back it up, I'm sorry. Back one slide. Because there's nothing to learn and nothing to do, that makes it really easy to use. Here's the manual. Now here's the list of things to do. We're finished. Training course over. Okay, and it's also very low cost to operate because there's no associated labor. But also, as we'll see in these benchmarks, just the running costs are much lower than a conventional database. All right. The Oracle Autonomous Database is serverless and truly elastic. What do I mean by serverless? I mean, when the database isn't running, when you're not running the database, you're not paying for any servers. When you're not running the database, you have 0 servers allocated to you, so you pay nothing for servers. You still pay for storage. You don't want to throw your data away. You want to keep the data. So you pay for storage, but if you're using the shared server version of the autonomous database, and we have 2 versions, when you're not running, it is serverless. It is a true case. It's a true case of you only pay for what you use while you're using it. It's very different than other clouds, which says, I want 4 servers for Redshift, I want 8 cores for Aurora, and you own those, whether it's running or not. It's not a serverless service. This is truly serverless. And adds capacity as it needs capacity for a month-end close, and then it releases all that capacity. Truly elastic and automatic. This is one of the reasons we can guarantee, if you use our database versus a database, any database at Amazon, we guarantee, bring in your Amazon bill, we guarantee to cut that bill in half. Maybe the most famous aspect of the autonomous database. Automatic discovery of threats, automatic remediation of threats while the database is still running. The database basically never stops running. You can upgrade it to new versions of the software. You can patch it. Hardware can fail, software can fail. None of it brings the database down. All of those things bring the Amazon database down. Everything I mentioned brings the Amazon database down. None of that affects the Oracle database. One of the reasons we can guarantee that the Oracle database is at least 25 times more reliable than the Amazon database, 25 times more available than the Amazon database. Okay, again, if we eliminate human labor, we eliminate human error. The great thing about autopilots is they don't make mistakes. They make the same mistake over and over again. Well, you pick it, then that's a bug. But the autopilot, no human labor, no human error. Huge improvement in reliability of your systems, much lower cost in terms of maintaining those systems. Amazon fails, again, for hardware failures, software failures, backup, upgrades. We don't, we keep running. Next slide. All right. By moving to the autonomous database, does that mean that all of your data, your database administrators are going to be out of work? Not hardly. There is an incredible shortage of skilled IT professionals on the planet Earth. And it's good if we take away some of the mundane drudgery about running a database. So they can use their talents to bring up new systems, use their talents to do a better job on data analytics, rather than making sure that the database is backed up once every day and manually scheduling those backups once every day, or having to physically recover the database if it ever goes down. All that stuff is automated. Your developers, your administrators are now working on tasks that are higher value for the business. The database, automation is great because typically people build a data warehouse, let's say, and they tune it. And then 6 months later, the data warehouse is 5 times, 10 times bigger than it was when it came online, and the tuning that was done 6 months ago is obsolete. The Oracle Autonomous Database constantly tunes itself and retunes itself and retunes itself. Automation is great. So something that human beings just can't and shouldn't do. The system constantly adapts to changing shapes of data, to changing workloads, constantly retunes and optimizes itself every time it runs. We've been working on this for a very long time. We've been optimizing and automating our database software for years and years and years. This isn't something we just came to all of a sudden. We've been adding automation, adding automation, adding automation, adding automation with every generation until We automated just about everything. And then we became autonomous. But it wasn't enough just to automate the database software itself to be autonomous. When you're running a database, you're not only running the database software, you're running the underlying operating system and hardware and servers and network, and there are all these other things you have to keep track of. You have to add storage capacity on all of that. We've also been automating database infrastructure for years in the form of Exadata. We've been automating the network and optimizing the network and automating storage and backups and recovery and all of these things. We've been automating things. We've been optimizing the operating system and the VMs that run the database. We've been doing that for years and years and years. And finally, when you combine automated infrastructure with automated database, with automated data center operations, and you completely automate those three parts, you get the world's first self-driving autonomous database. It took a long time to do. Okay, provisioning. It runs on Exadata. Well, the autonomous database runs on Exadata. It uses RAC, real application clusters, for scale out. And it uses Active Data Guard to create a copy of the database in a remote location. So it's highly available. If a server fails, it keeps running. If the data center fails, the Active Data Guard version of the database, it keeps running. So you've got complete disaster recovery built into the autonomous database. Security. Several things, I'll mention a few new things. One of the interesting things about the Oracle database is the database administrator who created the database and can see the structure of the database cannot see user data. It's the only database where administrators can't look at user data. We're the only ones that do that. And it's a feature called Data Vault. The management, manage and patches not just the database, but also the operating system. Online. So we have a version of the Linux operating system that our database runs on Exadata, that we run on Exadata, and we can patch that Linux operating system while the system is still running. Let's see. When a server fails, when database software fails, and one of our rack nodes goes down, the application doesn't see it. There's an application transparent failover. It's not that it automatically recovers itself and then a bunch of users are kind of kicked off the system that were on that node. That's not what happens. The users never see the failure. There might be a slight delay in processing. Maybe they'll see a 1 second, 2 second delay. But the application keeps running. The users keep running. It's completely transparent to the users. Data center fails. Your database fails over to a new location. Application keeps running, users keep running. It's serverless. You only pay for what you use. And it constantly optimizes itself using machine learning, and we get better and better at this. Every year, our optimizations are more efficient. For example, the latest version of the database never has a query performance regression. In other words, typically we come up with a new version of the database, we've improved our optimization, and out of 100 queries you've got running, 99 of the 100 run faster, but one of them runs slower. That's just the way it would work for years and years and years at Oracle. New version, we made most of the queries run faster with our new optimizer, but there were a few outlier cases where the query ran slower. That never happens anymore. Because now we put the new optimizer in, it recompiles all the queries, runs the query, and then in the new mode to say, is this faster? Is the new mode faster or the old mode faster? If the old optimized query is faster than the new one, it will use the old optimized query. not the new one. So 99 of your queries will run using the new optimizer, and 1 query will stay on the old optimizer to avoid all regressions. By the way, customers tested the hell out of our database to find these query regressions. It was a lot of labor on your part. I can't adopt the new version of Oracle because, I got to make sure that, some things don't, what if some things run slower? Nothing runs slower anymore. Autonomous database for data warehousing, autonomous database for transaction processing. One is designed for queries and analytics, and the other is designed for transaction processing and a combination of transaction processing and reporting, combination of mixed workloads. And that's very interesting, that we have one database. We have one database for data warehousing. Amazon has one database for data warehousing also called Redshift. We have one database for transaction processing. By the way, it's the same database we use for data warehousing. Amazon has a totally different database they use for transaction processing called Aurora. This is a huge problem for mixed workloads, which I will demonstrate shortly. Okay, data warehouses, we use a columnar format. Transaction processing, we use a row format. Different kinds of optimizations. And here's the data warehouse in action. So these are the blue bars are customer-tuned version of this application. The red bar is we just dropped all the indexes and reran it with the automated data warehouse. It turns out that the machine learning, the computer-optimized version of the application ran much faster than the human-optimized version in every case, for the stock exchange, for the manufacturer, for the bank. The automation is very effective, and the automation, again, it keeps automating over and over and over again. So ADW works extremely well, even when compared to experts who have tuned, human experts who have tuned this thing. It took a long time before a computer could beat a human being at chess. But that happened a while ago. And the latest technologies, computers are getting pretty good using machine learning in terms of doing certain kinds of complicated tasks that human beings do. And computers can be very competitive to take over those tasks. And this is one example where computers are now better than people. Even something that is professionally tuned, like the NetSuite workload. NetSuite, a lot of smart people working on it for years and years and years. The guy who did a lot of the design, the performance, was first in his class at Harvard in mathematics. Big deal. Still wasn't as good as the computer. And he's pretty smart. And there's a lot of very talented people, but even in this case, we're years and years and years of experts tuning an application. The machine learning, the machine-educated robots were better at tuning the application than the smartest people. And they used a lot fewer indexes than the human experts used. An announcement. The early versions of the autonomous database were on a shared Exadata machine. It was a serverless design. In other words, we allocated a server for you when you ran, and then when you stopped running, the server went away, and you didn't pay for it. So it was a serverless design to give the very lowest cost, provide the very lowest cost for our autonomous database users. We still have that option. We still have an option to run shared serverless. However, if you're very security conscious and you don't want any other users in your Exadata machine, you don't want a shared Exadata machine. You want dedicated infrastructure. You want complete isolation from other customers. We will provide you in our public cloud 100% isolation. You are the only customer. You are the only customer on that Exadata machine. And we've got an impenetrable barrier around that machine so that no other customers can get to it. It's completely isolated. We use our cloud control computers to surround that machine, and nobody can get at it. Same technology we developed when we re-architected the cloud. It really is a unique feature of the Oracle Generation 2 cloud. So you completely control that machine. Okay. Autonomous database cloud customer. I think I've actually mentioned this already, that right now we're on version 1 of our autonomous database cloud customer, but this summer, press a button, and database cloud at customer becomes autonomous database cloud at customer. Full autonomous capabilities. Press one button. Again, this is one of our most popular offerings, and it's going to be upgraded in place at your data center to have full autonomous database capabilities in your data center with a broadband link, a broadband pipe to all of your applications in your data center. You don't have to buy a new license to use our cloud. You bring your existing database license, your existing middleware licenses. You come to the cloud. You get Exadata infrastructure, autonomous database. Everything's automated. You pick shared serverless, and you get really, really low costs. Guaranteed to be half the price of what Amazon charges you. Guaranteed. More importantly, there's no labor. There's no human labor, there's no human error. There's no downtime. Your developers are more productive. They get new projects to market. They build analytic applications faster. Lots and lots of benefits besides. So if you want all of those benefits, you've got to be willing to pay less. All right. This slide says we run 5 to 10 times faster than Amazon. Simply not true. I think the best benchmark we have here, unless you count the one that's infinitely faster than Amazon, is 80 times faster than Amazon. Okay. So I'm going to go and I'm going to run a series. Okay, let me just look at, I think I got one more slide here. Again, continuous, 3 to 100 times faster than Amazon. It really should be 3 to 80 to infinite, depending on what you're doing. Automatic tuning, runs on Exadata, fastest infrastructure, tuned by computers and machine learning, delivers the lowest cost, highest reliability, highest availability. I'm going to just run a few benchmarks. It'll take me about 5 minutes, and then we're done for this morning, or this afternoon. Okay, so here is the first, this is going to be interesting. Now, we ran this benchmark last year, and I wanted to make sure that we still had an advantage over Amazon Redshift. So we ran a whole series of Amazon Redshift benchmarks, and this is, remember, Redshift is their data warehouse. So this is the autonomous data warehouse running against Amazon's Redshift. Okay, stop. Okay, so we're done. They're not done. And so they got a long way to go. We're about 8 times, I believe we're about 8 times faster. Still, we were 8 times faster last year. We're still 8 times faster. All right, let me go to here. They said my problem, I wasn't pressing hard enough on this menu. I've never heard that explanation before. There we go. All right. All right, so So that was the data warehouse. We're still 8 times faster than Amazon's data warehouse. This is autonomous transaction processing, not the data warehouse, versus Amazon Aurora. Aurora is their specialized transaction processing system. And let's just start this one up. I know last year we let Amazon start first, but I'm not going to do that this year. No more Mr. Nice Guy. We're going to start at the same time. And let's see how this goes. OK, we're 10% complete. They're getting close. They're 1% complete. Doesn't look good for Amazon. But they're trying. I wish we'd go faster. Okay. We're at 20%. They're still at 1%. Ah, they got 2%. Damn it. Okay, just rough estimate, we're 10 times faster, 8 times faster here also. But these aren't the interesting ones. But again, about 8 times faster and much cheaper. I'll have a summary for all of this. Let me just stop this. Stop. Stop. OK. Now I'll do this. And now this is my favorite. Remember I said Amazon has a data warehouse database, Redshift, and they have a transaction processing database, Aurora. Well, what if your application has transaction processing and reporting? Like, that's a really bad idea. You should never, ever do that. Because when you have, we have one database that does both things, but they don't do that. So what happens when you have this mixed workload of transaction processing and reporting? Again, Oracle has one database that does all sorts of things. We handle IoT, we handle real-time, we handle XML, we handle all sorts of interesting things. I mean, the basics of can we do reporting and transaction processing with the same database? Yes, we can. We've been able to do that forever. Amazon still can't do that. They're about, I don't know, 10, 20 years behind in database technology. Not even their database technology. Aurora's MySQL, they just took open source MySQL, which we develop, renamed it, made it no longer open source. They call it Aurora. They took Redshift from somebody else and just, but they didn't develop any of this stuff. That's not their business. OK, so I'm going to stop this. But we're at 49%. They haven't gotten to 1% yet. We're about, I think, 80 times faster than they are in a mixed workload. By the way, most workloads are mixed workloads. That's a problem at Amazon. OK, now let me show you Amazon's best database by far. It's not Aurora. It's not Redshift. It's Oracle. What happens if you run Oracle on Amazon? Well, it's much better. But it's still not as good as our cloud. We're still much faster. We're about 3 times faster and about half the cost, probably a little more than half the cost, when you run Oracle on our cloud versus Oracle on their cloud. But that's not the reason you run Oracle on our cloud as opposed to Oracle on their cloud. It's not that we're 3 times faster and less than half the cost. That isn't the reason. I can let this go a little bit further, but I've got a summary that will show, again, we're about 3 times faster and less than half the cost. Let me stop this and show you the next benchmark, the last benchmark, actually. This is really cool because this is the Oracle Autonomous Database running on our Gen 2 cloud versus the Oracle database running at Amazon. And what we're going to show you is what happens when our autonomous robots find a security threat. They immediately spring into action and patch the threat, remediate the threat, kill the threat, destroy the threat. Now, how does that compare to what goes on at, what happens at Amazon? Okay, I'm going to go back here. All right. Doesn't look good. I know if you're looking at the top bar, this top thing right here, and Amazon's having a problem. They are now patching the threat. RDS, that's the Amazon Oracle service, it's down. You have to take the system down. So in this case, we're infinitely faster than they are. You have to shut your application off. In fact, a human being has to figure out to shut the application off, patch the application manually, bring it back up. System's not available. By the way, with RDS, you're still paying for it. It's not serverless. Even when the system isn't running, you're still paying. So, which is kind of painful. So it's down, but you still pay for it. I'm going to stop it and then show you the summaries. Okay, so. Okay, these are all the summaries. So the first thing, we're 9 times faster, 8 times cheaper on a data warehouse application. In the first OLTP application against Aurora, we're 11 times faster and 8 times cheaper. These are all real benchmarks. They're running outside. You can check them. This is the best Amazon has to offer. This is their latest, greatest, best stuff. Okay, in a mixed workload, which is most workloads, a combination of OLTP with some reporting, we're 100 times faster and 80 times cheaper. That's a big advantage. 80 times cheaper is good. You can go to Amazon if you want to, but, you know, it's very expensive. A lot of people just think, wow, the Amazon cloud, really cheap. Not true. Not true. OLTP, okay, what's the best database you can run on Amazon? Oracle. But even when you run Oracle on Amazon, it's going to be, we're going to be 3 times faster and less than half the cost. And Amazon has none of the autonomous features. They have none of the reliability features. They don't have rack. They don't have self-tuning. They have no autonomous features, not available. They don't have active data guard. They have no disaster recovery. They have no server failure recovery. They have no software failure recovery. They have no automatic patching. They've got none of that. They've got none of that. And we automatically patch, as you saw, we keep running. The system keeps running. In this case, we are infinitely faster and infinitely cheaper. But just take the simple mixed workload. 80 times cheaper is good. I mean, that's a good competitive advantage. You'll never see that in the Amazon retail store. You'll never see them selling you like a polo shirt that's 80 times more expensive than one of their competitors. Okay. We invite all of our customers to try Amazon polo shirts and our autonomous database. Okay, and we now have free trials out there. We think, try it. I think you'll like it. In summary, We've re-architected our cloud from the ground up to develop these new Star Wars cyber defensives. Impenetrable barriers protect the perimeter of our cloud and keep threats from getting in, and then barriers, impenetrable barriers around each customer zone protect threats from spreading laterally from one customer to another. We have these separate network of cloud control computers that are virtually unhackable because we don't share them with anybody. There's no user code in our cloud control computers. A fundamental architectural difference between the way we built our cloud and the way Amazon built their cloud. Throughout our cloud, we have autonomous robots searching for threats, not just threats to our database, which automatically repairs itself while running, but threats to any aspect of our cloud. We search and destroy those threats. It's our robots versus their robots. It's our robots that keeps your data safe and prevents people from stealing it, and you finding yourself on the front page of a newspaper above the fold. There's no delay for human processes. There's no time for human processes. We have to react automatically. We have to react autonomously to these cyber attacks. The autonomous database. You eliminate human labor, you eliminate human error. There's nothing to learn, nothing to do. Your developers become more productive. They bring up new applications. They do a better job of analyzing data. Your system is more reliable. It never goes down. It never goes down. Thank you very much.